Hey there, welcome to our video, where we're diving into a fascinating problem today. The problem at hand involves a code snippet from computer systems, a programmer's perspective. We have a function called foo that takes in two short integers, performs some operations on them, and returns a result. When this code is compiled with different optimization levels using GCC 14.2, we get interesting variations in the resulting assembly code. In the provided solution, we observe that with the O3 optimization level, the order of instructions in the assembly code differs from the O1 level. Specifically, the subl instruction comes before the mul instruction. This reordering is actually quite helpful for performance optimization. By executing subl before mul, we can take advantage of instruction level parallelism. Both subl and mul can be executed simultaneously since they do not depend on each other. This allows for more efficient use of the CPU's resources. Now let's delve a bit deeper into why this reordering is beneficial. The test instruction in the code depends on the result of the subl instruction. By completing the subtraction operation first, we can start the test instruction sooner. This means that the test instruction can begin its execution regardless of whether the mul operation is finished. The goal is to minimize idle time for the CPU and keep the pipeline filled with instructions as much as possible for optimal performance. In summary, the reordering of the subl and the mul instructions in the assembly code generated with the O3 optimization level is aimed at improving the overall efficiency of the code execution. By enabling instruction level parallelism and ensuring that dependent instructions can proceed without unnecessary delays, the optimized code can make the most out of the CPU's capabilities. And with that, we've reached the end of our video. Remember to hit subscribe, like the video, and drop a comment below. Thanks for watching, and until next time.